I am so sorry. I forgot to record the meeting. All we did was cover some basic input stuff that Steve, I'm pretty sure, is covered in pretty detailed. So hopefully that is okay. Sorry again. All right. So next we're going to be looking at math operators in C++. And the good news is a lot of them you have seen before. Plus performs just like addition in regular math. When you have a plus b, it is going to be the result of those, the sum. A minus b is the same thing. Division is where we have some differences. So earlier today, Steve was talking about integer division, and this is really, really important that you guys understand this because you can get a lot of bugs in your program if you're using the wrong type of division. So earlier we were talking about data types, and we defined two numerical data types, one which was double and one that was int. And these perform very differently when it comes to division and modulo. The rest of them are basically going to act the same way. But what we're going to focus on right now is division. So integers, remember, are whole numbers. So there's no fractional component. Integers are like 5, 7, 20, 100, -5, etc. There's no fractional component. So when we divide two integers, for example, 7 divided by 2, this is all integers, remember? We can't have a fractional component. So what happens is it performs the operation, but anything that was supposed to be a decimal place, so when you do 7 divided by 2 on your calculator, you should get 3.5. Wait, nope, that's not a 5. That is not a 5. 3.5. But it's an integer, so we can't store this 5, so it's truncated. It's not even rounded, so that's important to note too. It doesn't go up to 4. Anything that happens after the decimal place, so for example, if we had a result that was like 9.99999 going for infinity, and we used integer division to get this answer, it wouldn't be 10. It's not 10. It's still 9, because the decimal place after decimal doesn't exist to an int. So all of this just goes away. So that's what happens with integer division. And then when you have any double in your equation, so if, for example, this was a 2.0 instead of a 2, this gets converted to a 7.0 internally. And now we have two doubles, and then we will get the 3.5 as expected. So it's good to note the differences between those two, and they definitely each have their applications. So multiplication performs just as it does in regular math, but it's important to note that AB is not valid. A times B with the X symbol is not valid. And going around a parenthesis also does not work. It has to be with this star symbol. So star symbol for multiplication, none of these are valid in C++. All right, last one of these guys is modulo. And modulo is kind of like the other piece to integer division. So earlier we saw that 7 divided by 2 integer division results in a 3. Well, what happened to the other 1? So modulo will get you the remainder. And to see this, all you got to do is go back to your very, very basic math and do your long division. We know that 2 goes into 7 3 times with a 6, and we're left with 1. This is what modulo would get. So if we did 7 modulo 2, we would get a 1. And finally, parentheses, they function exactly as they do in math. So if we were to put 1 plus 3 divided by 2, it would execute the 1 plus 3 first, make it a 4, divide it by 2, results in 2. So hopefully that's not too bad. Any questions on the basic operators before we do a program with them? I just wanted to cover them and get them out of the way before we actually use them. Alrighty. I'm going to clear this. And the next thing that we are going to do is a programming activity where we are going to convert temperature in Fahrenheit to the equivalent Celsius value using this formula. So it's going to involve some variables and it's going to involve some literal numbers. And we're going to have to figure out how to take this formula and apply it in C++. So I was wondering, do you guys like it when you guys tell me what to type and I type it on my screen? Or would you rather all be working on the exact same screen where you could type? All right, I will be typing. Okay, so the formula is this right here. I'm going to write it down because I don't think I copied this slide. All right, so the formula that we are using is Celsius, C equals Fahrenheit minus 32 and times 5/9. All right, so that is our formula. I have some stuff written here already, which is just the basic, you already know. We included IO streams, we have input and output. We are using namespace standard. I have 2 double variables, F and C. I have an input prompt for F, so it will get the Fahrenheit from the terminal. And now, how can I convert this formula into the equivalent C++ version? What would that look like? And you guys can type that in chat or write it, or type it in chat or say it out loud. I don't care either way. .com like as a website?
I'm sorry, I put in sin, C-I-N, and it changed it to
Oh, it's okay.
Sorry.
You are all good. No worries. Autocorrect will do that. Sometimes it makes it really bad. I've had bad experience with autocorrect. All right, so CN right here is input stream. So C out, these actually have meanings. C out, it means characters out. And that's exactly what it's doing. It's taking any characters that we have here, right? And it is sending them out to the terminal. So if I were to run this program like this, look at that. The characters in this statement went out and they showed up here. That's what it stands for. It stands for characters out. Similarly, CN, it stands for characters in. So what it's saying is when we use a CN statement, it's going to take anything that we type here, anything that we're typing, and it's going to take it from here and put it in whatever variable that we have in the statement. So it takes input. So if I were to type 5 right here, it takes the 5. So the user's typing this 5, right? It takes the 5, the CN stream does this, and it stores it in whatever variable that we have right here. So it's a way of getting information from the user for input. Does that make sense?
Thank you very much.
Yeah, of course. So that is what our CN is for. It's for taking input from the user. All right. So I'm glad we could clarify that. And thank you so much for asking questions. Definitely do that if you're ever confused on anything. All right. Of course, return 0 signifies the end of your program. So return 0 is something which should be at the very, very end of your main block. So all of your code goes in main, right? And return 0 should be the last thing that your program sees before it ends. And remember, your program executes in sequential order. First, we're going to create a double name F, then we're going to create a double name C, then we're doing a C out statement, and then we do all this stuff. And at the very end of our program, after we've gone down all the list of instructions, we see something called return 0. And what this means is it's telling your program to end. That's what return does. And the 0 tells your program that everything executed okay. So imagine if I spelled C out wrong, like this. Well, what's going to happen is C++ has no idea what this means now. It has no clue. So it's going to go down the list, right? It's first going to create the variable f. It worked. That's good. It's going to create the variable c. That worked. That's good. Then it's going to go to line 8 and it sees this thing and it has no idea what this is. So it exits the program. It never reaches this return 0 line. So it exits the program here. So your computer knows, since it never reached return 0, something went wrong in the program and there's an error. So return 0 is just a way to let your computer know, hey, everything in the program ran okay if I hit this line, and it also kind of ends your program at the same time. Does that answer that by chance? All right, great questions. All right, so if there's no additional questions, but if there are, please do say them. How are we going to convert whatever the user entered for degrees in Fahrenheit to the equivalent degrees in Celsius? What do you think I'm going to do for that? And the great news is a lot of these math operators were very similar to how they were in your basic maths. So hopefully this will make a bit of sense once we start doing it. All right, so this formula translates really well into C++. So what we're going to want to do is we're going to want to restore the result of whatever calculation that we create in the variable C. And how we do that is with an assignment statement. Remember, assignment statements work like this. We have an equal sign and then something on the left and something on the right. Whatever is on the right gets assigned to whatever is on the left. In C++, the equal statement does not necessarily mean equal to. It means assigned to. So if you're ever reading a line in C++ with an equal statement, it's best in your head to read it as this thing is assigned with this thing. So whatever is over here is going to get assigned over here, and this thing becomes that. That was a very difficult way of explaining this. Whatever is here on this side, on the right, the left will become that. So we need to figure out what C is going to be. So C is going to become the formula, right? The formula C, Celsius, is going to equal whatever the result of our formula is. So basically exactly as it's written here. All right, so we have our assignment statement. We have our variable that we want to store the information into. So the very first thing that I see in my formula is I have parentheses. And we can look at our chart. Parentheses, they work exactly as they do in math. So that's great. I can just put parentheses here. And within my parentheses, I'm going to use my variable f. Because remember, f is just a variable holding a number, right? We took input for f, and whatever gets stored in f, it's just a number, so we can use it like that. So we have f minus 32. And that's valid C++ code. It looks exactly like the math. All right, now we need to do times the value of 5/9. So this is where things get a little bit different. So I can't just do 5/9 like this. What's wrong? Exactly, I am missing the multiplication symbol, which in C++ is the star. So whenever you're doing multiplication, we need that star right there. Awesome. All right, and then we want to make sure that we do the order of operations correctly. So the 5 gets divided by the 9 first, and then we multiply it. All right, so we're going to assume that this formula is correct. Now, how would I output the temperature to only 2 decimal places instead of however many this results in? This is something you knew that you guys learned from lecture today. Do you happen to remember what it is? And if not, that's okay. Here, I have it on the slides, so you guys could reference it later if you ever needed. All right, so to output something to a certain number of decimal places, we use the library iomanip. So this is another library that's going at the top of your program. We're getting quite a few of these now. Where'd my slide go? There it is. All right, so what these libraries do is they enable you to use more stuff in C++. So what we're going to do is we put this with the rest of the libraries. They all go at the very top of your program. So the libraries that you include should be the first thing your program sees. So this one is called iomanip. and it stands for input and output manipulation. All right, so the next thing that we need to do is we need to format to 2 decimal places. So we do this using a combination that you'll see very frequently. This is just something you should memorize. It is cout fixed, and then we call set precision. This is something which is within this IOmanip library. And then we say the number of decimal places that we want to output to. All right, so let's go ahead and write that. So we do cout fixed. And what fixed does is it makes sure that when we output your number, it is not outputting in any scientific notation, because there's another way to do that, but we want it to be the regular number with nothing weird. And then we do set precision, and then we specify the number of decimal places. So we want 2 decimal places, and we can put 2 here. So one thing to note about this line right here, it will apply to any more output that you have in your program, not just the subsequent line. So it's not going to just apply to the C, but if we have more output in our program, like many more lines, it will all get outputted to 2 decimal places until we change this. And we just change it by just doing another line of this, and we can change it to any number that we'd like that. So that would change it to 6, this would change it to 3, and so on. So if you ever need to change it back from whatever number you set it to, you just call it again. All right. So what do you guys think? Are we ready to run the program? Let's give it a try. All right, so I'm going to compile my program, and I'm going to type the file, temperature convert. There is no errors, so we're going to do 8 it out. Enter the temperature in Fahrenheit. Let's do 80 degrees. All right. That is very, very wrong. Anyone know why that happens? By chance.
In class, he put something at the end of that cout fixed set.
Right here? Oh, you can also
Yeah.
put the variable that you want to output, like here. So if we wanted to output C, we can combine that all in one cout statement, like this. So if I were to recompile now, it's going to take the temperature, 80, convert it, and we're going to get the number, which is stored in C, outputted to 0.0. So you could put the variable right after if you'd like to, or you can put it on a separate line. It actually doesn't matter which way.
I have a question about that, what you just did.
Of course.
In class, well, at least I wrote down cout the fixed precision, and then he put 2, and then he put H times W, and then he said he didn't have to do it again. So what was that?
All right, so in class, H times W, H was a variable. So H was defined just like these two were, right? We had somewhere double H, and then we had double W, and these two were variables which held values. So we can just make up values for them right now, 2 and 4. So what's happening here is we're running the cout statement from left to right. So the computer sees a cout statement. Oh, it says, okay, and now I know, and I'm going to do something with output. I'm going to make sure that output is fixed. It's not going to be in scientific notation. Oh, wait, that output needs to be limited to 2 decimal places. Then it sees this. It sees an expression, H times W. Well, let's see. H has the value 2. W has the value 4. This results in 2 times 4 is 8. So what it's going to do here is it evaluates the expression, which has the value of 8. But then it sees, wait, I had this fixed precision thing. I need to make sure that 8 is outputted to 2 decimal points. So it's going to put the 0.0 at the end. So the H and W actually had nothing to do with outputting to 2 decimal places. It was just an expression in the same cout statement. So this is just a multiplication expression, just like we could put our variable C here and run it and everything would work. and we run it, and there is our variable C. But the thing to note here is the W times the H was just an expression. It's going to just say, what is W times H? It's going to figure that out. And then from there, yeah.
And then he went on to say that, and in his program, he showed us he didn't have to do it again for the other expressions, like plus.
Exactly. Yeah.
Oh.
So when we run this fixed set precision command, we only actually have to run it once. So check this out. I'm going to go ahead and assign these guys some values just for the sake of this example. So this has nothing to do with the program that we're writing right now for everyone else. I just want to show you guys a point here. So I have a variable F and a variable C that has nothing to do with Celsius and Fahrenheit at the moment, but I'm going to output them. I'm going to do C out. And if I wanted to output F, I would just do C out F and then endo. This is normal, right? And then if I wanted to output C like that, this is just two normal C out statements, right? And this is just two normal variables holding numbers that happen to have decimal places at the end. And I'm going to remove anything that is not in reference to what we're talking about right now. All right, there we go. Two variables, the set precision, and then two C out statements. Let's run our program. Look at that. It took my two variables, and both of them are formatted to only two decimal places, right? I only had to call this one time. So when I call the fixed set precision statement, any subsequent output statements that I run will be outputted to two decimal places. So this originally had 3. This originally had 3. We told it, no, you must have 2. So any single output statement that I run in the future will only have 2 decimal places. And if I wanted to change that, say, hey, wait a minute, I want 3 decimal places now. Well, what I'd do is, let's just say we want to do F again. And this one I want to 3 decimal places. What I could do is, remember, these statements execute in sequential order. So I'm putting this here. Now I want to, let's do 4 decimal places. Let's see. Look at that. So the first 2 only outputted to 2 decimal places because that's what we told it to. It saw this line, and now it knows for any future C out statement with a number, only outputted to 2 decimal places. So see this one. It's like, okay, I have F, I need to only output it to decimal places. There it is. I have C, I want to only output it to 2 decimal places. There it is. Then it gets another C out statement, and this resets the number of decimal places it's supposed to output to. So now it says, okay, any future C out statement with number, I am outputting that to 4 decimal places. Then we reach this one. It says, okay, I have a number. Well, that needs to be outputted to 4 decimal places. So there it is right here.
So the expression that he put, this H times W, doesn't change the fact that we're putting in other expressions. It doesn't matter.
Exactly. Yeah.
Okay.
It's just like tacking another thing onto the C out statement. Just like I could technically do this. It's still a valid C out statement. I just tack some more stuff onto it. I can just keep adding more and more stuff to C out statements if I wanted to. They don't have to be like all broken up on different lines like this. So just like a regular C out statement, we can tack stuff onto the end of this, but it's not actually affecting the set precision thing. So if you want to use set precision and don't want to be confused by what do I need to put in the end, this is your syntax. If you wanted to output decimals to a certain number, it is C out, fixed, set precision, however many decimal points, semicolon, and then just continue as normal. Does that make sense?
Great. Thank you.
Of course. Yay. All right. Great questions. All righty. So I'm going to bring back our code for converting Celsius and Fahrenheit. And last time we saw it when it was the code that we were looking at. I uncommented too much stuff. All right. There we go. Now it's back to normal. So last time I ran this, we got some very strange output. We are at 80 degrees Fahrenheit. That is 0 degrees Celsius, and that is not correct. So where did I go wrong? If anyone knows, it's a tricky one. And I want to see if anyone can catch it. Well, we just saw that set precision was working. We just saw all those examples where set precision was outputting your decimal places to the correct number, and all that was working. We know these variables are correct. We just used them. This is just a cout statement, and this is a cin statement. We could check this. We could say, is there anything wrong with the cin statement? This is just a cout statement. That's all working fine. It's doing exactly what it's supposed to. It's something that's happening with this variable c. It's not storing what it should. It's storing 0.0, or technically 0, instead of whatever the result of this expression should be. Let's go through this expression with our number here. So the expression that we have is f. So we take our variable f. Well, f we assigned with 80. So it's just like math. We replace the f. 80 minus 32 times 5 divided by 9. All right. So just like math, first thing we're going to do is we're going to go to the parentheses. Oh, and this squares in parentheses too. That is important. All right, so we're going to take our 80, we're going to minus 32, and we're going to get 48. And this is going to be times, well, what is this? What's the value of that expression? What's 5 divided by 9? On my calculator, it says 0.555555555 going on forever. But in C++, what is that? That's something a little bit different. Remember, we look at this as integer division. 5 is an int. 9 is an int. What do you know? Integer division, we do 9, 5. How many times does 9 go into 5? 0. And then we have stuff down here that we don't need to worry about. 0, remainder 5. This is your answer right here. This expression right here resulted in 0. So we have 48 times 0, and this is going to be 0, and hence the 0.0. Does that make sense? Why that happens? Hopefully it does. Any questions on that in particular, please let me know. And if not, and this all makes sense, how do I fix it? Well, the issue that I had here was my 5 and my 9 were both integers, and thus I performed integer division. So instead, what I'm going to do is I'm going to make one of these a double. It doesn't matter which one I choose, as long as something in the expression is a double, it will now start doing the double floating point math. So now it's going to give me the correct expression here. All right, there we go. So we made one thing in the expression a floating point. This is going to translate into a floating point for the expression. And now we should not be getting zeros. All right, so let's run this. Get it out. 80. There it is. All right, so that fixed the problem. The equivalent temperature in Celsius is 26.67 degrees, and we can verify this on Google if we wanted. Let's see. Fahrenheit, we said 80. And there it is. It is 26.666667 going on forever, I assume. And with our IOManip, we were able to fix this so it wasn't going on forever. And our formula worked as expected. Yay. All right, any questions on that? Why we needed to change this to a 9.0 or anything in this program? All right. Well, great job. That is the end of that program. I'm gonna go back to my slides. So we could do one of two things with the rest of our SI session. We have around 15 minutes. We could do another practice quiz like we did last week, where I have the quiz and you guys would help me with answering A, B, C, and D, and we talk about why answers are the certain way they are. Or we can write a program, another one that will be a calculator. So the user will enter 2 values and then we calculate the sum, the difference, the quotient, etc. What would you guys rather do? All right, one person says they want to do a calculator, so we will do that. And this will be left for Thursday. All right, and as you guys know, you can take this if you want to. It's not required. Already been over that, but just letting you guys know. And we'll do that one Thursday. All right, so we are going to do the calculator program. So this is going to be similar, in which we're taking input for numbers and we're doing arithmetic with them. Let me get that up. Okay, so this is the instructions for the calculator, along with its example outputs. So we're going to write a program which takes 2 inputs and it's going to calculate the sum, difference, product, and quotient of all those inputs. And we're going to output our calculations as shown down here. So this one, I did not have any file started, so I'm having you guys do this all the way from scratch. So I'm going to start by creating the file. And I'll just name it calculator. And there it is. I'm going to open that real quick. Okay. And this is going to be a completely blank file. So you guys are going to have to tell me everything that goes in it from the beginning. Good practice to know how to write them from complete scratch. All right. I have my empty program here. What do I start with?
I think you put include less than IOStream greater than.
You are absolutely correct. We need to include IOStream. Right. And including IOStream allows us to use cin and cout. So we definitely need that. All right, what comes next? All right, this next line we don't worry about too much in this class about what it means, but it's using namespace standard. Typed out like that. And it allows you to use some stuff in what's called the standard library, but don't worry about that. Just know it will go in every single one of your programs this semester. All right, what do we do now? Well, every C++, yeah, there you go, someone got it. Every C++ program ever will have something called int main. And it looks like this. It has curly braces, and all of your code for now is going inside of these curly braces. This technically is not really counting as code when I say that, like this stuff. This is technically called preprocessor stuff. Don't worry about that. But all of your code, all your variable definitions, all of your cout statements, all of that should be going inside of this box. It should be between here and here. And there we go. All right, nice. So lastly, for the setup of our program, the last thing we need is return 0. And return 0, it just tells your computer my program ran okay, and it exits your program. All right, cool. So now we have the basic structure of our program down. Now it's time to analyze the problem and figure out how we are going to make this program work. So we need 2 inputs from the user. I think that's a good place to start. How am I going to do that? And remember, inputs are like this 80 that we put right here. It's something that the user types in that we need to store, and then we can use it later on. That's an input. So when we take input, notice how I said that the 80 is something that we need to store. So we need something that we can actually store it in. And in programming, we store things in variables. So I need to create 2 variables, one for each of these inputs here. And I'm going to choose the data type double, just so then when we use our calculator, it will function like a normal calculator and we'll get double arithmetic rather than integers. So I'll create a double and I'll call this one A and I'll call this one B. All right, so that created 2 new variables that we can use. So now I need to do this part of the program right here. How do I do that? Yes, exactly. We need a cout statement, which is going to serve as our input prompt. So it says enter enter a number. And no endl on the end of that cout statement, I'll put one more. Enter another number. All right. And semicolons at the end of all of our C++ statements. All right, so there are our cout statements. Now we actually need to do the part that takes the inputs. This is the important part. This is kind of all set up. How do we actually take the input? So I'll say that 5 should go in A and 9 should go in B. How do I do that? Yes, all right, awesome, someone got it. It is the CN statement. Remember, CN stands for characters in. So what it does is it takes input that we type over here on the terminal, and it takes it and it stores it in whatever variable we tell it to. So the syntax is CN, and we have our little caret characters here. And then we have whatever variable that we want to store that input in. And then we're going to do one more of those for the B variable. All right, so good practice is to compile our program just to make sure everything that we have done so far is correct. All right, so everything compiled, we can also run it if we want to make sure that it's running correctly. 5 and 9. My input prompts look good. We can't actually tell for sure that the input went into the variables, but I can tell you that this is all correct, so it did. So everything in our program is looking great so far. All right, so the next part that we need to do is this final part of our calculator where we do the sum, difference, product, and quotient. So how do I do that? Well, this looks like output going back to the user. So we're going to use the cout string. And I'll use a string literal, just like before, to say sum. And then I'm going to, what am I going to put here? Calculate the sum. We can actually do this inside the cout statement. That's A plus B, just like in math. So what's going to happen is program is going to go down, it's going to see your cout statement. It's going to see that it needs to output this string literal. It's going to go over the console, output that. And then it sees this expression here, and it's going to evaluate the expression. It's not going to type A and then B like that. It doesn't work like that. When you have an expression, it evaluates the expression, and then it outputs whatever the result is, and then we will print an end line. So we're going to do the same thing for the rest of these. Difference, and this is going to be A minus B. And then we have cout product. And this is A times B. Remember, in C++, it has to be the star. And finally, the quotient. This is going to be A divided by B. So that's just a whole bunch of cout statements. Hopefully, you guys are all okay with what I just typed there. Oh, what did I do? And I am missing the stream insertion operators. All right, so these guys are important. So the compiler told me I am missing a semicolon in the middle of my line. We know that's not true, but what we do know is when we see an error, it can give us a lot of valuable information. The first thing it gives us is the line number that it got confused. So right here, this is really good information, the 1521. It's telling me that line 15, I'm going to move this over so you guys can see the line numbers. Line 15, it has a problem. And then the 21 is the character number in that line that I've had that problem. So 21, you're not going to find very helpful, but the 15 is going to be very helpful. So we know that our error is likely on line 15. It can either be on line 15 or above 15. It will never be below 15. And why is that? Well, your program is executing from top to bottom, right? It's going here, then here, then here, then here, then here, then here. The line that the error is on is the line that the compiler got confused. It's like, wait a second, something's actually wrong here. So usually your error is on that line Or sometimes there's something wrong up here, and then it finally realized when it got to that line number, wait a second, that's actually not right, and then it just quits. So it's either on line 15 or above. And luckily for us this time, it was line 15 and not too bad to figure out. All right. Uh-oh, did I not save? I didn't save. All right, get it out. We're going to enter a number. I'll do the ones that I have in the example, 5 and 9. And that looks correct to me. There's all your outputs. And the cool thing about the variables and taking inputs is we can use any numbers that we want, 7 and 9. We could use ones with fractional components because we have our doubles. So there is your very, very basic calculator. We'll get a more advanced one in the future where we can actually specify, do we want the sum, do we want the difference, or do we want the product? But that is the basics for now. So do you have any questions on this or anything that we talked about today? All right, well, if not, thank you guys so much for joining. On Thursday, we will definitely look at that debugging input and arithmetic quiz. I'll probably add a few more questions to that, just to add some new material, whatever Steve decides to cover on Thursday. And then we'll also take a look at the stuff from CMath, and we'll write a calculator for the quadratic formula. So that should be interesting. And yeah, thank you guys so much. Feel free to stick around if you have any additional questions. And if not, I already have your attendance, so you are good for extra credit, and I will see you next time.